You've been working with factoring perfect square trinomials. Now let's look at another special situation called factoring a difference of squares. Right? So this may look familiar to you. Remember when we had two binomials that were the same except for the operation, one had plus and one had minus. When you multiplied these two binomials, do you remember the special product that you got? What is it that happened? Well, if you distribute the x times the x, you got x squared, and then distribute the x times the to the negative 4, and you got minus 4x, and then distribute the 4 to the x, and that gave you plus 4x, and then distribute the positive 4 to the minus 4, and that gave you minus 16. And what do you see here? You have like terms, a minus 4x and a plus 4x. The x terms make a zero pair, meaning they cancel out, and that leaves you with x squared minus 16. That is an example of a difference of squares. X squared you can get by squaring x, obviously. Difference means minus, and 16 is a perfect square. How can you get 16? You can get 16 by squaring 4. So your first term is the square of x, your second term is the square of 4, you're subtracting. That's why they call these differences of squares, and they're easy to factor. So if you had x squared minus 16 and you needed to factor it, since this is a perfect square, working backwards to what you just got, take the square root of x squared, you get x. That's your first term. Take the square root of 16, you get 4. That's your second term. And in order to make this work, one of the operations has to be plus, one has to be minus. And when you distribute all of this, it takes you to x squared minus 16. So this would be the factorization of x squared minus 16. Look at this one. First of all, is it a difference of squares? We need to know if we can factor it. N squared, obviously yes, square root of n squared is n. 9 is a perfect square, the square root of 9 is 3. And difference means subtraction, and in this case we're subtracting. So we know that if we want to factor this, first of all, yes, it's a difference of squares, and then if we want to factor it, our two binomials are going to be n and n. That gives us the n squared, and then 3 squared will give us 9, and we just have to make 1 plus, 1 minus. There's our factorization. What about this one? X squared is a perfect square, so you can get x times x. 100 is a perfect square, you can make that as 10 times 10. So are you thinking, yes, I can factor this as x plus 10 times x plus 10? Hopefully you're saying no, because what do you see here? You have addition. So if you were to multiply this out, x times x is x squared, x times the 10 is plus 10x, and then distribute the 10 here, you get another plus 10x, and then 10 times 10 gives you 100. And what do you notice? Those middle terms do not cancel out. That would leave you with plus 20x, so that would not take you back to the x squared plus 100. So no, if it's got addition in the middle, it's not going to make a difference of squares, and you can't factor it the way we've been doing. Look at this. Look at 25x squared. Can you take the square root of that? Yes. 5x times 5x is 25x squared. Difference means subtract. We've got minus, so that's good so far. And square root of 49 is 7. So we can put a 7 here. So 5x plus 7, 5x minus 7. If we were to multiply these two binomials, it would take us to 25x squared minus 49. So yes, that's a difference of squares, and this is how we would factor it. Look at that. You might think 12 is not a perfect square. You might think 27 is not a perfect square. But remember, when you're factoring, you always want to think about, can I take out a GCF? Well, can you? What's the greatest common factor of 12 and 27? You can factor 3 out of both. So if you factor 3 out of this binomial, that leaves you with 4x squared minus 3 times 9 is 27. So now look at 4x squared minus 9. Is that a perfect squared? Yes, it is. So you can factor 4x squared as 2x times 2x, and then the square root of 9 is 3, so it's going to be 2x plus 3, 2x minus 3, and don't forget the 3 outside the parentheses. So this would be the complete factorization of 12x squared minus 27. You were able to factor out the 3, make a difference of squares. So now you are familiar with this special situation where you have difference of squares, and you see how easy they are to factor.